Picture the universe as a grand, ancient book, its pages written in the light of stars, its chapters carved by the forces of gravity, time, and energy. For decades, we've been reading this book, confident we understood its opening lines. The Big Bang, the rapid expansion, the birth of galaxies. But now the James Webb Space Telescope has turned to a page we didn't expect, and the words don't make sense. Galaxies, massive and impossibly ancient, glow in the telescope's infrared gaze, their light traveling for billions of years to reach us. These aren't the faint, scattered star clusters we predicted for the universe's infancy. They're colossal, structured, and far too mature for their time. It's as if we opened a history book to the chapter on ancient civilizations and found skyscrapers and supercomputers. The math doesn't add up. The universe, it seems, has been keeping secrets, and they're spilling out in ways that make even the most seasoned cosmologists question everything. The warning came like a thunderclap in a quiet lecture hall. A Nobel Prize winner, whose work helped cement our understanding of the universe's origins, stood before a room of peers and admitted the unthinkable. Our models might be wrong. Not just tweaked, not just adjusted, but fundamentally, catastrophically wrong. The James Webb Space Telescope has revealed galaxies that shouldn't exist, structures so massive and well-formed they defy the timeline we've built for cosmic evolution. According to our best theories, the universe began 13.8 billion years ago in a fiery explosion of space and time. In its earliest moments, it was a chaotic soup of particles, too hot and turbulent for stars or galaxies to form. Yet, just a few 100 million years later, barely a cosmic blink, these monstrous galaxies were already there, shining with a brilliance that screams of a past we don't understand. It's like finding a fully grown adult in a crib. The universe is either older than we thought, or something else is rewriting the rules. Let's step back and unpack this. The Big Bang Theory, the cornerstone of modern cosmology, tells us that the universe expanded from a single infinitely dense point. As it cooled, particles clumped together, forming hydrogen, helium, and eventually the first stars. These stars gathered into galaxies over hundreds of millions of years, slowly building the cosmic web we see today. But the James Webb's images are throwing a wrench into this story. Some of these early galaxies are as massive as the Milky Way, with intricate structures that should have taken billions of years to form. The telescope's infrared vision, peering deeper into the past than ever before, shows us light from when the universe was less than 1 billion years old. And yet these galaxies aren't the primitive, half-formed things we expected. They're fully fledged, with stars, gas, and even hints of supermassive black holes. It's as if the universe skipped a step, or several. This isn't just a puzzle, it's a crisis. Cosmologists call it the early galaxy problem, and it's sending shockwaves through the field. If these galaxies formed faster than our models allow, we're missing something fundamental about how the universe works. One possibility is that our timeline is off. Maybe the universe is older than 13.8 billion years, giving galaxies more time to grow. But that would mean rethinking the cosmic microwave background, the faint echo of the Big Bang that we've measured with exquisite precision. Another idea is that galaxy formation was wildly more efficient in the early universe, driven by forces or conditions we don't yet understand. Perhaps dark matter, that mysterious substance making up a quarter of the universe's mass, played a role we haven't accounted for. Or maybe something even stranger was at work. something that bends the laws of physics in ways we can't yet imagine. The Nobel Prize winner's warning wasn't just about galaxies. It was about the very nature of reality. If our models of the early universe are wrong, then everything built on them, our understanding of dark energy, the expansion of space, even the shape of the cosmos, could be suspect. Dark energy, the force driving the universe's accelerating expansion, was discovered by observing distant supernovae, a discovery that earned the Nobel Prize. But if the universe's early history doesn't align with our predictions, could dark energy be something else entirely? Could it behave differently than we thought, or interact with matter in ways we haven't modeled? The James Webb's data is forcing us to confront these questions head-on, and the answers might demand a complete overhaul of cosmology. Now, let's dive deeper into the strangeness. The James Webb has also spotted something else: cosmic structures that don't fit. In the early universe, we expected a chaotic mess of stars and gas, not the organized patterns we're seeing. Some images show galaxies aligned in ways that suggest a hidden order, like threads woven into a cosmic tapestry. Others reveal vast voids and filaments, structures that shouldn't have had time to form so early. These aren't just anomalies, they're clues to a deeper truth. One speculative theory gaining traction is the idea of a multiverse, a collection of universes, each with its own physical laws. What if the James Webb is seeing echoes of another universe brushing against ours? What if these galaxies are shaped by forces leaking across cosmic boundaries? It sounds like science fiction, but so did black holes a century ago. The multiverse idea is tantalizing, but it's not the only explanation. Another possibility is that dark matter isn't what we think. We've long assumed dark matter is a stable, invisible substance that clumps together to form the scaffolding of galaxies. But what if it's more dynamic, capable of triggering rapid star formation in the early universe? Some theorists propose that dark matter particles could interact in ways we haven't detected, speeding up the process of galaxy formation. Others suggest that the first stars, known as population 3 stars, were far more massive and luminous than we thought, kickstarting galaxies at an unprecedented pace. Each of these ideas pushes the boundaries of what we believe is possible, and none of them come without trade-offs. Let's talk about the emotional weight of this discovery. Imagine dedicating your life to understanding the universe, building equations and models that explain the stars, only to have a telescope show you something that doesn't fit. It's humbling, exhilarating, and terrifying all at once. The Nobel Prize winner's voice carried that weight, a mix of awe and unease. "Something strange is happening," they said, and those words echo through the halls of science like a call to arms. This isn't just about fixing a broken model, it's about embracing the unknown. The universe is daring us to rethink everything, to question the rules we've held sacred. It's a reminder that science isn't a destination, it's a journey, one that thrives on uncertainty and wonder. The James Webb Space Telescope itself is a marvel, a testament to human ingenuity. Its golden mirror, spanning over 21 feet, captures light that's been traveling since the dawn of time. Its instruments, cooled to just above absolute zero, can see through cosmic dust to reveal the universe's infancy. Every image it sends back is a window into the past, a snapshot of a cosmos that no longer exists. But it's also a mirror, reflecting our own limitations. We built this machine to answer questions, but it's asking new ones instead. Why are these galaxies so massive? Why do they look so mature? What forces shaped them in a universe that was supposed to be a chaotic newborn? These aren't just scientific problems. They're philosophical ones, touching on the nature of existence itself. Let's consider the implications. If the universe is older than we thought, what does that mean for its future? Our current models predict a cosmos that will expand forever, growing colder and darker until stars burn out and galaxies drift apart. But if the timeline is wrong, maybe the universe has more surprises in store. Perhaps it's cyclical, collapsing, and reborn in an endless dance of creation. Or maybe it's part of a larger structure, a multiverse where our reality is just one bubble in an infinite foam. These ideas stretch the mind, forcing us to confront the limits of our imagination. They also remind us of our place in the cosmos, not as masters, but as curious observers, forever chasing the truth. The Nobel Prize-winner's warning also points to a practical challenge. Science thrives on precision, and the James Webb's data is pushing our measurements to their limits. To confirm these strange galaxies, astronomers are cross-referencing the telescope's findings with other observatories, like the Hubble Space Telescope and the Atacama Large Millimeter Array. They're using computer simulations to model how galaxies could form so quickly, tweaking variables like dark matter density and star formation rates. But every simulation comes up short, unable to fully explain the observations. This is where the real work begins, not just in crunching numbers, but in daring to think differently. The universe is handing us a puzzle, and we need to be brave enough to try new pieces. One of those pieces might be the Hubble tension, another cosmic mystery that James Webb has amplified. For years, astronomers have noticed that the universe's expansion rate, known as the Hubble constant, varies depending on how we measure it. Observations of the cosmic microwave background suggest a slower expansion, while measurements of nearby supernovae point to a faster one. The James Webb's data, with its precise measurements of distant stars, has confirmed this discrepancy isn't a mistake. It's real. This tension could be linked to the early galaxy problem, hinting at a universe that behaves differently at different scales. Some propose a new force, a tweak to gravity, or even a previously unknown particle. Whatever the answer, it's clear the universe isn't playing by our rules. The emotional pull of this moment can't be overstated. There's a thrill in the unknown, a rush that comes from standing at the edge of discovery. But there's also fear, not of danger, but of the vastness of what we don't know. The Nobel Prize winner's words carry that duality: excitement for what the James Webb is revealing, and unease at what it might mean. If our models are wrong, we're not just rewriting textbooks, we're rethinking our place in the cosmos. Are we alone in a universe that's far older and stranger than we imagined? Are there other realities, other laws of physics, brushing against our own? These questions aren't just scientific, they're existential, touching on the very meaning of existence. Let's zoom out for a moment. The universe is vast, but it's also intimate. Every atom in your body was forged in the hearts of ancient stars, stars that might have shone in those early galaxies the James Webb is seeing. When we look at these images, we're not just studying the cosmos, we're studying ourselves. The light from those galaxies has traveled billions of years to reach us, carrying stories of a universe that's both alien and familiar. It's a humbling reminder that we're part of something much bigger, a cosmic drama that's been unfolding since the beginning of time. And now, With the James Webb, we're catching a glimpse of the opening act, and it's not what we expected. The speculative possibilities are endless, and that's what makes this moment so electric. Could the James Webb be seeing the fingerprints of a multiverse where our universe is just one of many? The idea is controversial, but it's not as far-fetched as it sounds. Quantum mechanics suggests that reality might branch into multiple outcomes, and some theories propose that the Big Bang was a collision between universes. If that's true, the strange galaxies and structures we're seeing could be echoes of that cosmic crash. Gravitational waves, thermal anomalies, or even light from another reality. The Nobel Prize winner hinted at this, suggesting that the universe might be part of a larger, more complex structure. It's a mind-bending idea, but it's one that science is starting to take seriously. Then there's dark energy, the mysterious force that makes up nearly 70% of the universe. We know it's driving the cosmos to expand faster and faster, but we don't know what it is. The James Webb's discoveries could be hinting at a new role for dark energy in the early universe. Maybe it wasn't just a latecomer, pushing galaxies apart in the modern era. Maybe it was active in the cosmic dawn, shaping those massive galaxies in ways we haven't modeled. Or perhaps dark energy interacts with dark matter in unexpected ways, creating pockets of space where galaxies form faster than they should. These are uncharted waters, and the telescope is our only guide. The human side of this story is just as compelling. Scientists are grappling with these findings in real time, their careers built on models that are now under siege. There's a sense of urgency, a race to understand what the James Webb is showing us. Conferences are buzzing with debates, papers are flooding journals, and every new image from the telescope is dissected like a sacred text. Yet there's also a sense of unity. This isn't about one scientist or one discovery, it's about humanity as a whole, reaching out to touch the stars. The Nobel Prize winner's warning wasn't just for astronomers, it was for all of us. The universe is speaking, and we need to listen. What does the future hold? The James Webb is just getting started. Its mission will continue for years, delivering more images, more data, more mysteries. Each new observation is a chance to refine our theories, to test ideas like the multiverse or dynamic dark matter. Other telescopes, like the upcoming Vera C. Rubin Observatory, will join the effort, mapping the cosmos with unprecedented detail. Meanwhile, theorists are working overtime, crafting new models to explain the early galaxy problem and the Hubble tension. Some are even revisiting the foundations of gravity itself, wondering if Einstein's equations need a tweak to account for these cosmic oddities. The universe is a puzzle, and we're only just beginning to see its shape. There's a poetic beauty in this uncertainty. The universe doesn't owe us answers. It owes us wonder. Every time we think we've cracked its code, it throws us a curveball, reminding us how small we are, how vast it is. The James Webb Space Telescope is more than a machine. It's a messenger, carrying whispers from the edge of time. Those massive, impossible galaxies, those strange cosmic structures, they're not just data points. They're invitations to dream, to question, to explore. The Nobel Prize winner's warning is a call to embrace that invitation, to let go of what we think we know and chase the truth, no matter how strange it seems. This is where the real adventure begins. The universe is alive, dynamic, and full of surprises. It's not a static backdrop, but a story still being written, with plot twists we can't predict. The James Webb is showing us that the cosmos is stranger, wilder, and more beautiful than we ever imagined. It's challenging us to rethink not just our science, but our place in the grand scheme of things. Are we the only ones watching this cosmic show, or are there others out there in other universes marveling at the same mysteries? The answers are out there, waiting in the light of distant stars. If this feels overwhelming, it should. The universe is vast, and its secrets are vaster still. But that's what makes it so thrilling. Every new discovery is a chance to grow, to stretch our minds beyond the limits of what we thought possible. If you want to sharpen your own intuition, to train your mind to wrestle with the mysteries of the cosmos, there's a way to start. Interactive platforms can guide you through the wonders of math, physics, and data science, letting you solve problems and build understanding step by step. It's like training for a cosmic marathon. Each puzzle you solve strengthens your ability to grasp the universe's strangeness. So, when the next bizarre signal comes from the James Webb, you'll be ready to meet it with wonder, not fear. The universe is calling. It's telling us something strange is happening, something that could change everything. The James Webb Space Telescope is our window into that mystery, and the Nobel Prize-winner's warning is our wake-up call. We're standing at the edge of a new era in cosmology, where the rules we've lived by might no longer apply. Will we find a new theory to explain these impossible galaxies? Will we uncover evidence of a multiverse, or redefine dark matter and dark energy? Only time and more data will tell. But one thing is certain. The cosmos isn't done surprising us. So let's keep looking up, keep questioning, and keep chasing the truth, no matter how wild it gets. The universe is waiting.